So we're in section 8.1, sequences and series. And so a sequence is a function whose domain is a set of natural numbers. So it's 1, 2, 3, 4, 5, and so forth, right? The term is sequence are the function values, and so we usually write an instead of the function notation. So we'll have the first in the sequence, second, the first term, second term, third term, the nth term, and so forth, right? So we call this the first, second, or the nth term. Okay. And so what we have from here is are in the first 5 terms of the sequence. And so here we're just going to say, so here our very first term will be 2 times 1. So here we'll have a1. So a1 is equal to 2 times 1. So 2 times 1 minus 1, which is equal to 1. And then the second term will be a2 is equal to 2 times 2 minus 1, which is equal to 3. So here we have our first terms to be 1, 3. The next term here would be just 2 more than that, so it'll be 5. The next term will be 7. The next term will be 9. And then we want to find which term? The 100th term, right? And so here the 100th term would be 2 times 100 minus 1. So n100. So a100 would be 2 times 100 minus 1, so it would be 109. It would be 199. And then this keeps continuing. All right. Here, we can just do the same thing here. So b1, in this case, so b1 would be 1 over 1 plus 1, which is a half. Here, b2 will be 1 over, or 2 over, sorry. Be on the right layer. 2 over 2 plus 2, or 2 plus 1. So it'll be 2/3. And so the sequence is a half, 2/3. Oops. 3/4, 4/5. So what's the 5th term? What's the 5th term here? What would be the next term in the sequence? Yeah, 5/6. And then the 100th term would be 100 over 100 plus 1. So it'll be 101. And then it goes forward. Okay. Here's another one. So let's look at this one. So here, C1, I'll just plug in 1 into here, and I get 1 squared minus 1, which is 0. C2, I'll have 2 squared, which is 4, minus 1 will be 3. And so here I have 0, we'll have 3. 9 squared minus 1 would be 8. 16 squared minus 1 would be 15. 25 squared minus 1 would be 24. 100 squared. So 100 squared would be, and so we just have 9,999. Just be that minus 1. So that's our 100th term. Here we have an alternating sequence. And so what you'll see, so anytime you have this -1 to the end, what happens is it alternates. And let me show you that. So D1 will be -1 to the first power over 2 to the first power, which is just minus a half, right? D2 would be -1 to the second power, and so that becomes positive over 2 to the second power, so this is positive a fourth. And so here it would be -1/2, positive 1/4. Here, if it was the third power, it'd be negative up top, and then be 2 to the second power, so it'd be -1/8. And so we call this an alternating sequence where it's positive, negative, positive, negative, positive, negative, positive, negative, right? The next one would be positive 16. The next one after that would be minus 32. And then the 100th one, I'm not writing out 2 to the 100th power. It's just too dang large. So it'd be 1 to the 100, -1 to the 100th power, which is positive 1, times 2 to the 100th power. And I'm not writing that out. Why am I not writing out? Anyone have a clue how big that is? Let's find out. Where? Oh, See, I was almost going to open up attendance and then I didn't. Stay on page. But I did move my attendance off, so it's not the attendance I show, so I don't have to cut the video. Hey, look, it's still trying to process the thing we typed into Wolfram Alpha to solve that. Still hasn't figured it out. Anyways, let's type in 2 to the 100th power. Yeah, 2 to 100 power. It is this small number right here. So no, I'm not writing that down. But anyways, that's just how the sequence goes. Okay, so let's just keep going. Oh, that's the end of this. All right, so given this, all right, so here, now we're going to have to put our thinking caps on, and we're going to have to figure out what is the formula for this, right? So find the nth term of the sequence for first one's given this. So let's put our thinking caps on. What is, if I have 1 over 2, so A1 is equal to 1 over 2, and A2 is equal to 3 over 4. A3 is equal to 5 over 6. And so I want the A to the nth term. So what I would like to do is I like to look at it in isolation. So if I have something over something, I like to look at the top and I like to look at the bottom. So let's look at the top. So the top goes 1, 1, 3, 5, 7. So this is each going up by like 2, right? This goes up by 2, this goes up by 2, this goes up by 2. And so what I'm thinking is I have 2 times something minus 1, right? So here we have 2 times n minus 1. Does that work? Yeah. Because I'm always 1 less than 2, 1 less than 4, 1 less than 6, 1 less than 8. So that's where I get this from. So what is the bottom? Here I have 2, 4, 6, 8. So what's the bottom here? What would I write for the bottom? Yeah, 2 to the n. Okay. And so these are just like little puzzles you solve. Here we have an alternating sequence. And so it starts negative. And so here, you know that a to the n has some sort of the n power. So notice how it's negative, and then positive, then negative, then positive, then negative. And then, oops, because I forgot a comma there. And so in this case, we use this. And this is what allows us, because -1 times itself is -1. -1 times -1 is +1. -1 times -1 times -1 is negative, and then positive. And so this just allows you to alternate. So anytime you see alternating signs, you're always going to put this. And then here we just have 2, 4, 8, 16, 32. So what should I put here? What's the second part? It's -1 to the nth power times what? Yeah, 2 to the n, right? And so here would be 2 to the first power, to the second power, to the third power. And so here's just a way of just kind of figuring out what it is. Okay. Now, could you put this together? Sure, right? You can have -2 to the nth power. It works out fine, actually. But I like to keep it separated. I like to keep this like that. Okay. All right. So somehow I don't think I saved my last page of these notes. All right. Let's go to the next page. All right, so recursive sequences. So the nth term of a sequence may depend on some or all the preceding terms. This sequence is defined in a way which is called recursive. And so here, we'll show you some recursive relationships. See something super fast. Yep, I did not save it. That's good to know. All right, so here we have a recursive relationship. So here we have I know what the first term is. I tell you what it is. It's 1, right? So A1 is equal to 1. And I say a to the n is 3 times a a to the n minus 1 plus 1. So here, a to the 2 is equal to a to the is equal to a1 plus 2. 3 times a1 plus 2. So here, I'll let n equals 2. So 3 times, well, what's a1? It's 1. So here I have 3 times 3, so this is 9. Okay? Because I know what a1 is. It's 1. So 1 plus 3, or 1 plus 2 is 3. 3 times 3 is 9. a2, a2, so we want to put in the first 5. So a3 is equal to 3 times a2 plus 2. Do I know what a2 is? Yeah, it's 9. 9 plus 2 is 11. 11 times 3 is 33. So notice here, we're just going to use this formula. So it'd be, so if I have it, so my next one's a4. My a4 formula would be a4 times 3 times 4 minus 1, which is a3, plus 2. Well, a3 is 33, plus 2 is 35. 35 times 3 is 105. Okay, and then we'll just find a4, or a5. a5 is equal to 3 times a4 plus 2. And that is equal to, if I crunch through the number, we 30. 107. 107 times 3 is 321. Okay. So 321. So the sequence goes 1, 9, 33, 105, 321, and so forth. Okay. All right. So here we're going to have a very famous one. This is the Fibonacci sequence. And so we have 1, 1, and then it's the sum of the last two. I think at some point, you probably have seen this one. So we have 1, 1. F3 would be equal to F2 plus F1. Well, that's 1 and 1, so this is 2. F4 is equal to F3 plus F2, so the one before it and the one before that. So this would be 3. The next one will be this one plus this one, which will be 5. The next one is this one plus this one, which equals 8. The next one is this one plus this one, which is 13. And this is this one plus this one, which is 21. The next one's the last two before it. So 21 plus 13, which gives us 34, and so forth, right? So, and so here we have, this. So it would be 1, 1, 2, 3, and this is the Fibonacci sequence. This is the famous one that you've probably seen. If you ever watched Donald Duck and Math Magic Land, that one comes up a lot. Have you guys ever seen Donald Duck and Math Magic Land? It's an old Disney thing. I don't see any yeses. It's a sad world. It's a sad world. No. Let's see what happens at the end of class. All right, so for a given sequence, we can have a partial sum. And so we list this as S1 equals to A1, S2 equals to A1 plus A plus 2, S3, S4 is just how many sums. So Sn would be the first n sequences. And so this is called the first partial sum, second, the nth partial sum. And this sequence gives you a sequence of partial sums. And so here, a sequence can produce a sequence of partial sums, and you can just do this ad infinitum. Okay. All right. And so we're going to do some partial sums. And then I'm going to show you some sigma notation. And then we're going to do some sigma notation. And then we're going to call it good for the day. And oh, come on. I want to pull up something super fast before we do this. Why am I doing this the hard way? You ever ask yourself why you do stuff the hard way? Because I do every day. It's like, why are you doing it the hard way? I saw Dr. Mathematics there. Thank you, Tyler. Thank you. You make my life complete. I have my answers, but my little answer key didn't come with my answers. But this is literally no different than when I teach in my Math 124 class or my Math 127 class. So let me just cheat and make sure I have the answers up. There we go. All right, so let's do this. So we're going to find the first 4 partial sums and the nth partial sum of the given sequence. All right, so let's do this. And so here, so here we're going to find the first 4. And so we have a to the, so s, well, here, if anyone the first 4 partial sums, I probably should have the first. Let's actually just lay out. So this is the first term, this is the second term, this is the third term, and this is the fourth term, right? So here's our first 4 terms. Everyone okay with this? How I got this? So it'd just be 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4. So S1 is equal to just equal to A1, which is equal to a half. S2 is equal to A1 plus A2, which is equal to a half plus a fourth. And so if I add those two up, this becomes 2/4 plus 1/4 equals 3/4. Here, if I have S3 equal to A1 plus A2 plus A3 is equal to a half plus a fourth plus an eighth, not 1/8, right? So I have to make, so this is 4/8 plus 2/8 plus 1/8 is 4 plus 2 plus 1, which gives me 7/8, right? And if we do S4, this would be A1 plus A2 plus A3 plus A4. So that's a half plus a fourth plus an eighth plus a 16th. So this is 8/16, 4/16, 2/16, 1/16. So this is 15/16. All right. So in this case, let me write out my S sequence. And so my S, the sequence here is a half for the S's, right? So Sn is equal, or S, the sequence of the sums, right, is equal to, so here it's a half, 3/4, 7/8, 15/16. And so can you guess what the next one is? Can we guess what the next one is? What's probably the next one? If you can guess that, I can probably get you to what the answer, what the general answer is. Can we guess what probably the next one is? Something over 32. All right, so 32. Well, how much is this off by? How much is this lower by? Yeah, 31 over 32. Yeah, you guys are really close. And actually, that's it, 31 over 32. So in general, so in order to find the nth partial sum of some sequences, you calculate like 4 of them. You get a little sequence here. You kind of figure out the pattern. So what's the pattern in general? So Sn is equal to 2 to the n minus 1, just one lower than 2 to the n, right? And so here we can have a general answer for this. Okay. And so these are like little puzzles you have to solve. I don't think the homework makes you do it too much. I'll double check with you before the end of class. So let's do the next one. So here we're going to have 1 over n plus minus 1 over n plus 1. And so what we want to do here, in this case, I'm actually not going to figure out what the answers are. And that might seem kind of crazy what a to the n is, because this ends up working out nicely. So it's like s to the n is equal to at a1, which is equal to, a1 is equal to 1 over 1 minus 1 over 2, right? 1 over 1 minus 1 over 2. So this is equal to, hold on. So this is equal to 1 minus a half is, of course, a half. So let's do S2. S2 is equal to A1 plus A2. Well, A1 is 1 over 1 minus 1 over 2. A2 would be 1 over 2 minus 1 over 3, right? But notice here that these two cancel each other. And so I have this, and so this is equal to 2/3. Let's do S to the third. It'll be A1 plus A2 plus A3. So here I'll have 1 over 1 minus 1 over 2. So this is A1 plus 1/2 minus 1/3. This is A2 plus 1/3 minus 1/4, which is A3. But notice this cancels this cancels this, and so I'm just left with 1 over 1 minus 1 over 4. And so here I got 3/4. And here, S4 is going to be A1 plus A2 plus A3 plus A4. But now we kind of see the song and dance. It'll be 1 over 1 minus 1 over 5 because everything else will cancel, right? And so what do I get here? I get 4/5. Okay. So what is it? What is Sn in general? Well, it's just 1 minus 1 over n plus 1, right? That's what it is in general. And we kind of figured that out just because what happens is when we add the next one, the middle parts cancel. And then we add, so here this canceled and these two canceled. And so we're just left with that. Okay. All right, so let's talk about sigma notation. I'm not positive your homework makes you find these. But we'll double check real quick. Let's do sigma notation. And we'll call it good. All right, so let's look at this. So, oops, hello. Here we go. So sigma notation. So this is the Greek letter S, and it's capitalized. And so what we have here is where we start. So we're going to start at 1, and we're going to end at 5. And so, or here, I'm looking over here. We're going to start at 1. We're going to end at n. So we're going to go 1, 2, 3, 4, all the way up to n. And here's our series, whatever our series is. So, oh, someone's. Let me go ahead and mute somebody. Whoop. There we go. All right, so what do we have here? Uh-oh. After all that, I ruined where I was at. Okay, so here. That's why I think it wants to play. All right, so here, let's do this. And so we have, so we're going to start at 1, we're going to go to 5, and we're going to put in, everywhere we're going to see a k, we're just going to put in 1. So this will be 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. And so 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. And so this ends up being, that's a 10, that's a 20, or so 55? Yeah, it ends up being 55. How I did that in my head is this is 10, this is 20, so that's 30, 30 plus 25 is 55. Okay. Here, we're going to start at 3. So notice we're starting at 3. We're going to end at 5, and it's just 1 over j. So it'd be, so this is equal to 1 over 3, because we're going to have j equal to 3. We're going to go j equal to 4, so 1 over 4. And then j equal to 5, so plus 1 over 5. And that's where we end. We end at 5. So a third plus a fourth plus a fifth is 47/60. Just crunch it to a calculator, right? Here, we're going to start at 5. We're going to go to 10, and we're just going to let it equal to I. So this is equal to 5 plus 6 plus 7 plus 8 I said 8. I wrote 6 plus 8 plus 9 plus 10. This is equal to 45. Okay. Go ahead and try D. What is D? Try this on your own. Tell me what the answer you get is, and then I'll go through it with you. See if someone gets to the answer. All right, what am I doing? I am opening up the homework as you guys do that. Notice here, I'll give you a hint. The first one is 2. The second one is also 2 because it doesn't care what it is, right? The sequence doesn't care what number you're on. It'll output 2. So what's the answer? Maybe that will get you close enough. All right, what am I doing? 12. Yes, 12 is the answer. So our first term is 2. Second term is 2. Third term is 2. Oops. Third term is 2. Fourth term is 2. Fifth term is 2. The sixth term is 2. So 2 plus 2 plus 2 plus 2 plus 2 plus 2 is 12. Yep, that's it. All right, so we're going to work a little